Today, we're tearing down the Anker Nano 10,000 mAh Wireless Power Bank A110Z. Its key features combine magnetic wireless charging and a digital battery display. It also provides full data monitoring and uses 2 ATL battery cells from the same supplier as Apple. The power bank features a flat rectangular design in pure white. The edges of the body are smoothly rounded. The housing has also undergone an S.2 level flame retardant upgrade. It also features Level 2 safety protection under UL 2056. The front features a magnetic wireless charging panel. It has a circular texture and a lightning bolt symbol. There is also a vertical alignment mark for easier positioning. The back has a recessed storage area for the stand. A silver metal folding stand is built into it. The stand features an anti-slip texture when unfolded. It can also be held securely in place by the magnetic structure when stored. One side of the power bank features a rounded rectangular power button and a digital display. It shows the remaining battery level and estimated charging time in real time. The other side features a single USB-C port. It supports both input and output. The product specs and certification marks are also printed here. It can be taken on a plane. The included cable is about 62 centimeters long. It uses an integrated injection-molded connector design. The cable ends also feature extended strain relief sleeves. The power bank measures 107.3 millimeters in length. The width of it is about 68.97 millimeters, and the thickness of it is about 21.82 millimeters. It weighs about 238.7 grams, making it fairly portable. The magnetic hold is strong. It can hold a phone suspended without letting it fall. When wirelessly charging an iPhone 17 Pro Max, it does not block the rear cameras. The folding stand can also support the phone in either portrait or landscape orientation, which allows you to use the phone while charging. The USB-C port supports multiple fast charging protocols, including QC 3.0, SCP, and PD 3.0. In our testing with the iPhone 17 Pro Max, wired charging power reached 25.03 watts. It can also access a smart monitoring website when connected to a computer. You can view detailed data such as battery health, cycle count, voltage, and current in real time. The digital display also shows the status info at the same time. Now let's begin the teardown. We open the housing along the seam. The inside of the magnetic charging cover contains a circular magnet array. It also has a vertical alignment magnet. A large graphene heat dissipation sheet is attached to the upper section. The area corresponding to the mainboard is insulated. The internal layout is clear, with the PCB mainboard located at the top. Its surface is covered with gray thermal potting compound to help dissipate heat. The battery and wireless charging module are located in the middle and lower sections. The digital display on the left connects to the mainboard through a flexible ribbon cable. An electrode pad on the right detects whether the phone is properly attached. The wireless charging coil is located in the middle and lower section. It connects to the mainboard through wires. An alloy metal plate provides insulation and separation between the coil and the battery cells. An NTC thermistor extends inside the coil to monitor temperature and prevent overheating. Insulating paper is placed between the battery cells and the PCB. Black foam fills the gaps around the seams. The NTC thermistor is secured with potting compound and covered with high-temperature insulating tape. Black foam is attached to the bottom housing around the battery cell area for cushioning and support. A white plastic sheet insulates the area corresponding to the mainboard. The surface of the module is covered by a metal plate. The wireless charging coil is secured in the center. The battery module consists of 2 ATL New Energy 606,072G pouch cells connected in series. Each cell has a capacity of 5,000 mAh. The complete unit has a capacity of 10,000 mAh and a nominal voltage of 3.91 volts. Its rated energy is 39.1 watt-hours. The battery cells have passed CCC certification. As for the key components, the back of the battery protection PCB features a Chipsea CBM8580 KCV battery protection chip. It is designed specifically for lithium battery packs with 2 to 4 cells connected in series. There is also a dual N-channel MOSFET marked 2002. 2 LeadTech LT7401 FLCB P-channel MOSFETs are used as power control switches, which are rated at -30 volts. The PCB mainboard is the main control area. The front contains a memory chip, wireless charging controller, switching MOSFETs, and other components. The back contains the power bank controller, synchronous buck-boost MOSFETs, a USB pass-through chip, and other components. The power bank controller is the INJOINIC IP5385. It is the industry's first synchronous buck-boost SoC with integrated UFCS universal fast charging. It supports up to 65 watts and is compatible with multiple fast charging protocols. It works with 4 LeadTech LTS7906 FL N-channel synchronous buck-boost MOSFETs. They are rated at 30 volts and form a stable charging and discharging circuit. The wireless charging section uses a Southchip SC8329 synchronous boost converter, a CPS WB8118 wireless charging management chip, and a CPS 1010 authentication chip to form a complete solution. The WB8118 supports Qi 215-watt wireless fast charging. It is paired with a 40 MHz passive crystal oscillator. There is also a LeadTech LTS1582 FPC resonant capacitor switching MOSFET. It is rated at 60 volts and helps ensure stable wireless charging output. The USB-C port uses a LeadTech LT3810 FPJ as its V-bus switching MOSFET. It uses a dual N-channel MOSFET design, and it is rated at 30 volts. The mainboard also features a WCH-CH9347 USB pass-through chip. This enables communication with a computer. It also supports fully transparent tracking of battery cell data. A Chipsea CS32L015K8V6 MCU drives the digital display. A voltage regulator marked 8DLPB supplies power to the MCU. A Yukon UC25HD40 memory chip stores the data. There is also a current sense amplifier marked GS2TH for current monitoring. 2 Raylon electronic solid filter capacitors are rated at 25 volts and 100 microfarads. They help maintain stable power delivery. Finally, here is a list of the product's key components. This magnetic wireless power bank with a digital display has a compact internal structure. The overall build quality is solid. At its core, it uses high-spec ATL battery cells. It also uses key chips from leading brands such as INJOINIC and Chipsea, as well as CPS and other major suppliers. Together, they form a complete wired and wireless fast charging control system.